All right, hi. Okay, so this objective is about deriving and using formulas for volume. So we're dealing with a new concept called volume today. Before we get into that, let's go over our important vocab. You'll see area, that is the space inside a shape. I can't write. Okay, so draw like a little rectangle and color it in. That's the area. Dimension is the measure of a length. I'll show you an example of that in a second. So when we, for example, if we're going to find the area of a rectangle is a width and a length. And the area formula for that is length times width. So the dimensions of the area are the length and the width. Those are the lengths that make up a rectangle. Area of a triangle is, when we have a triangle, you can calculate the height from the top to the bottom of the triangle that forms that 90-degree angle. We call that side our base, call that the height. Those are the dimensions. Those are some of the dimensions of a triangle. And then area equals 1/2 of the base times the height, or base times height divided by 2. Area of a circle, how we find that? So we have a circle. Remember, the radius is the distance from center to edge. And the formula is pi times the radius squared. And now, base of a figure, you're going to hear that word a lot today. It's the bottom of a figure. So if the figure is sitting like on the ground, what part of the figure is, what shape is touching the ground, okay? So we're going to get into volume. We'll skip over this, but we're dealing with a few different shapes today. We're going to deal with a cylinder, a cone, a rectangular prism, and a pyramid. And again, these are three-dimensional figures. All right, and so how do we find the volume of this? So first of all, what is volume? Volume is the total amount of space inside a solid. So for those figures I just showed you, if you were to like fill them with water, it's like how much water would fit inside the figure is the volume of the figure. To find the volume of a solid, you can use formulas like we did with surface area in the previous video and lesson, but you can also use this idea. If you take the area of the base, the bottom of that figure, and multiply it times the height. I'll show you what I mean by that in this example, okay? So example 1 is if we're dealing with a cylinder that has a diameter of 10 inches and a height of 8 inches. What is the volume of the cylinder? In inches cubed, we're going to start using cubed inches because we're talking about three-dimensional space right now. Okay, so first thing I'm going to do is draw a cylinder. Okay, then I was given the diameter is 10, so from edge to the center is 10. I'm going to write that out. Diameter equals 10, and then the height was 8. So h equals 8. Now, I don't have a formula yet, but if I think about finding the base of this figure, so the bottom of this figure is a circle, right? It's this circle, right? Where, if I find the area of that circle, area of the circle is going to be equal to pi radius squared. Went over that in the vocab, okay? So if I insert my information, now I'm noticing this is the diameter and I need radius, so I will cut that diameter in half and get 5 for the radius. And then I'm just going to plug into my formula. Area equals pi times 5 squared. Area is going to equal 5 squared is 25. So the area of inside here is 25 pi. Okay, just that flat circle. Now, if I think about this many areas stacking on top of each other, stacking all the way to the top, they're going to stack for 8 inches high. So that's why I can just take my area of my base, which is, again, this guy, and be like, okay, 25 pi times my height of 8, and just multiply them together. 25 times 8 is 200 pies. So the volume would equal 200 pies inches cubed, because we're talking about three-dimensional space now. Okay? So that's one way of figuring out volume, is again, that idea of area of the base times the height. There are also a bunch of formulas, so I'll show you on the next page. There are formulas we can use as well. And make sure you write these down really carefully. Okay? Sorry, one sec, guys. Just finding my notes. There they are. Okay. So, for a cube with a side length of s, the formula is s. Notice that's an s, not a 5, okay? S cubed. For a rectangular prism, where the dimensions are length, width, and height, all you have to do is the length times the width times the height. For a pyramid, you just have to do 1/3 times its length times its width times its height. And then for a cylinder, you just have to do, that's going to be, like we just said, like we just kind of computed, pi r squared times the height. For a cone, you need to do 1/3 pi r squared times the height. And then for a sphere, the formula is 4/3 pi r cubed. Okay? So, let's look at example 2 really quickly. And let's think about it as using our formulas, okay? Because when I look at this, I'm like, okay, we're going to try using we'll try using our formulas, okay? So, what I need for this is, if we're finding the volume of this pyramid below, I'm going to use the pyramid formula, which tells me volume is going to equal 1/3 length times width times height. Now, when I think about what my numbers are, my length is going to equal, my width is going to equal, so the length and width are here and here. So that's going to be 12 and 10. Now my height, though, actually is not given in this example. I know we have this diagonal here, but that's slant height, right? If we think of that from that's the slant height. Okay, that's not the actual height. The height is going to be the dimension that goes from the top to the bottom and makes a right angle. So we don't actually have that. So in this case, we could solve for it. I'm gonna stop here though. I'm just gonna use this as an example to say like, hey, do not use the slant height. Okay, so we do not know the height of this. So, and we're not gonna solve for it. You can, but we're not gonna deal with it now. Okay. For 3, so we're gonna move on to example 3. So again, that was meant to just show don't use slant height for your height for a pyramid. Okay? Now when we look at example 3, let's use our formula again. So find the volume of, it's a cone, so I'm going to use 1/3 pi r squared height. Okay? Before I plug into that formula, I am going to find my dimension. So it looks like I need the radius, and it looks like I need a height. Okay, so when I look at what I'm given, this is all the way across. This is actually the diameter. So radius is going to be 10. So that's half, right? And then the height, again, this is our slant height. This 22 is a slant height, so that's not the height. So in this case, we're going to have to solve for the height. And I'm going to actually show you how to do it in this example, okay? So a height, again, is how tall the cone is. It would have to make from, bottom to top of the cone and make a right angle. And so what we notice here, actually, is when I do this, I make a right triangle that's 22 by, we don't know what this is, again, that's our height. This is going to be 10, right? So we get this little like right triangle. That's 22, 10, and then we don't know the height. And we can do a squared plus b squared equals c squared to solve for that. So I'm going to do 10 squared plus my h squared equals 22 squared. Because again, of the right triangle that forms inside that shape. So I'm going to get 100 plus h squared equals 22 squared is 384. I'm going to subtract 100. I'm going to get h squared equals what? 284. And then I'm going to take the square root, and that's going to give me h is 19.6 when I did that math. Okay? So I found that my h is now 19.6. So now it's just a matter of plugging in this information into the formula. So volume is going to equal 1/3 pi. Radius is 10 squared times my height we just found was 19.6. Okay? When I do all that math, if I multiply my 1/3, oh no, I'm sorry, I got to do 10 squared first. So I'm going to get volume equals 1/3 pi times 100 times 19.6. Okay, when I multiply this and that times the 1/3, I'm going to leave pi alone and just multiply these three numbers, 1/3, 100, and 19.6. You get 653.3 repeating. And then again, pi inches cubed. That's our final answer. Okay? All right. Cool. And then last key points box I'm going to show you quickly is the last key points box where we're going to find the missing dimensions given volume. So I'm given the volume, how can I solve for like a length within that volume, okay? So, for example, if I'm finding the length of a radius of a cone, so I want the radius of a cone that is 10 inches tall and has a volume of this, okay? So if I draw myself a little cone, okay, and I want the length of the radius, so I'm looking for that, okay? The cone is 10 inches tall, so that's 10, and has a volume of 30 pi cubed. So what I can do here is set up an equation using the volume formula that matches the shape. This is a cone, so I'm going to use the volume formula for the cone, and then solve for the variable. The variable that matches the missing dimension, okay? So volume of a cone, volume is 1/3, and it's okay if you have to go back to your notes to figure this out, 1/3 pi radius squared, right? And what do I know about this shape? Well, I already know, oh, I'm sorry, times the height. Duh. Okay, so I already know, I was told that h is 10. I want the radius, right? And I know the volume is 30 pi. That's the information the problem gave me. So I'm just going to plug in what I know. Volume is 30 pi. 30 pi's will equal 1/3 pi. Radius we don't know, so I'm going to keep it a variable. But h we know is 10. Okay? And so now, I'm going to solve this equation that I have here. I'm going to make pi go away because it's on both sides, so I can just cancel it out. Okay, and then I'm going to rewrite this as 30 equals 1/3 times 10 is going to be 10/3 times r squared. Okay, and then I can multiply the reciprocal, or I can divide by 10/3 to solve this. When you do that, you're going to get rid of the 10/3. When you do that, you're going to get r squared equals 9. And then take that square root. And I get r equals 3. And that's it. Hope that made sense.